Okay, with chapter 9, packet number 2, we're going to be talking about rotations that are going around other fixed points, not necessarily the origin. Okay, so it says right here, a figure can be rotated around any fixed point. So this would be the fixed point right here. So that's the point 2, 3. So what you actually do is you're going to draw vectors from each one of the points in the triangle and do the same thing over there. Okay, kind of. So the vector here is 1, 2, 1, 2, 3. So the vector right there is 2, 3, both positive. Okay, so 2, 3. So here, since I'm rotating it 90 degrees counterclockwise, a 90-degree counterclockwise x comma y would be y comma x, and it would be negative y right there. Okay, so what I'm going to do to the vector is I'm going to flip-flop that. So the 90-degree rotation would be 3, 2, but this y becomes negative. So it would be, this new point is going to be at negative 1, 2, 3 up to vector, not the point negative 3, 2, but the vector negative 3, 2. So hopefully that makes sense. All right, so let's go to this one. So go ahead and pause your video. Make sure you've got the triangle drawn and the rotation point drawn in right there. Okay, so pause your video, draw in that triangle and the rotation point, and we'll talk about the vectors. Okay, so the vector from P to X is, it would be 3, 5. So make sure you're doing the X direction first. From P to Y, it would be 7, 3. And from P to Z, right there, it would be 5, 1. Okay, now, if it's saying 90-degree counterclockwise rotation, then we need to do that. The x comma y goes to negative y x. We need to do that to all of our vectors. Okay, so then the transformation would be negative 5, 3. This one would be negative 3, 7. And this one would be negative 1, 5 right there. Okay, so now let's plot those vectors. Okay, not points, vectors. So P, I'm going to go 1, 2, 3, 4, 5, 1, 2, 3. Okay, that's my x. So x prime. Okay, and then from here, I'm going to go negative 3, 7 from the y value. So negative 3, 1, 2, 3. I'm sorry, not from there. Oh my gosh, from here. I was like, what am I doing? So I'm going to go negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, I guess that's a common mistake. Don't go from the original points. Go from the point of origin, the point of rotation, which is not the origin. Okay, so right here, I would go negative 1, 1, 2, 3, 4, 5 right there. Okay, so that would be Z prime. All right, so here's my new triangle, and it was rotated. So see how the X is down there, the Y is over there, and the Z is over there, counterclockwise, around a point, 90 degrees. Okay, so right here, I have the points. This would be negative 4, 5. Y would be negative 2, 9. And Z prime would be 0, 7. Okay, so let's check out this one. All right, so go ahead and pause your video, draw in the rectangle, and draw in the rotation point. Okay. All right, so I already did that. So we're doing 180-degree rotation. So I always write my rule first, which is I just changed the signs of both, right? So there's my rule. So let's do our original vectors. So the AC vector. Okay, so let's start with C. So I would go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So AC vector is negative 4, 7. Remember, vector form, the component form, not an ordered pair. Okay. AD. So let's go A to D. So that would be negative 1, 1, 2, 3, 4, 5, 6, 7. Good. Makes sense because it's a rectangle. Okay. E would be negative 1, 2. And F would be 1, 2, 3, 4, negative 4, 2. And then you know your memorized transformation for a rotation of 180 degrees is just changing all the signs. So my new ordered pair should be my new vectors. Why do I keep doing that? My new vectors. So I'm going to draw an arrow to show I'm doing the transformation. Okay, so it would be 4, negative 7. I was going directly to the points, but that's not the points. These are the vectors right here. So you actually transform the vectors and then we'll name our points. Okay, it was going too fast right there. So negative 1, 7 would be 1, negative 7. Okay, that would make sense. They would have to be lined up to be a rectangle, right? And then negative 1, 2 would become 1, negative 2. And negative 4, 2 would become 4, negative 2. Okay, so let's do all those. So from C, I'm going to go 4 down, over 4 down 7. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Did I do that right? And then what did I just do right now? What am I doing right here? Okay, so 4, negative 7. All right, so go ahead and 1, 2. So this would be at the point, I've got it. Okay, so C would be at the point 1. There we go. Okay, so that's C prime. Okay, so if you looked at what I just did again, okay, and I caught myself, I don't think I was talking out loud, but if you don't go your vector from the point, go your vector from the center of origin. So the orientation, the rotation point, okay? So I think I did that. I think I went 4, negative 7. I'm like, that's not right. That's because you don't go from the corners. You are supposed to go from the center of rotation. Okay. So it would be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. Okay. This one would be 1, negative 7. So that's D prime. And the next one would be 1, negative 2. So that is E prime. And then 1, 2, 3, 4, negative 2. That is F prime. Okay, so I'm definitely making a common mistake, so be careful with that. Okay. All right, so that's the point. Let's see. That's a point 1, negative 8. D is the point negative 2, negative 8. E is the point negative 2, negative 3. And F is the point 1, negative 3. There we go. Okay. So there's that. All right. We're not going to go through all of these, but let's go ahead and take a peek at this one down here. So watch out. It's clockwise. So when it says clockwise, we need to remember that we are going to actually do the counterclockwise rotation. So the counterclockwise would be, so think about it again. So if I went 90 clockwise, that's 270 counterclockwise. So 270 counterclockwise. Okay. So what is that transformation? That is x comma y. We switch our y and our x, and we make our x values change signs. Okay, so let's go ahead and plot the information. Actually, let's just do the vector form. We don't need to graph all this. Let's do the vector form. So from P to J, well, actually, I have to graph it because I can't count. I could count, but I don't want to do it like that. Let's just do it. 1, 2, 3, 1, 2, 3, 4, 5. I was going to count from it the stair steps, but I might as well just graph it. So there's J, K is 0, 8, and L is 1, 2, 3, 1, 2, 3, 4, 5. So there's L, and M is 0, 2. There's M. Okay. The point of rotation is negative 4, 0, 1, 2, 3, 4. There's our point of rotation. I need to do from P to J. From P to J, that's 1, 5. Okay. From P to K, that is 1, 2, 3, 4, 8. And from P to L, that would be 7, 5. And PM would be 1, 2, 3, 4, 2. Okay, so now we are going to do our transformation on the component form right here, the vector form right here. So I'm going to switch all of them. So let's draw an arrow that we're switching them. And I'm going to switch 5 and 1. I'm going to switch 8 and 4. I'm going to show you how some kids do this. I'm going to switch 5 and 7, and I'm going to switch 2 and 4. Okay, but I have to make all of these last ones change signs. So negative, 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 and negative right there. Okay, so 5, -1, 8, -4, 5, -7, and 2, -4. So don't go from the ordered pairs or the order pair points. Go from the rotation point. Okay, so I'm going to go 5, -1. 1, 2, 3, 4, 5, -1. And I get J prime. I'm going to go 8, 2, 3, 4, 5, 8, -1, 2, 3, 4, 8, -4. That would be K prime. And then I'm going to go 5, -7. I keep counting when I actually know it's 8 by 8, but that's okay. So there's L prime. And then let's go 2, 1, 2, 1, 2, 3, 4. And that's M prime. Okay, so J, K, L, M. There it is. And you'll see that it got turned 90 degrees clockwise. Okay, so the final ordered pairs are, let's see, 1, -1, 4, -4, 1, -7, and -2, -4. All right, so be careful about the clockwise one. Use your counterclockwise rotation. Okay, so on this worksheet, we have 1, 3, 5. Let's do the odds. 1, 3, 5. And let's do 6 and 7. Instead of 6 and 7 and 8 and 9, do 6 and 7. That'll consider your odds right there. Okay, like an odd problem. All right, let's move on that. So here, whoops, what did I do here? Okay, go ahead and pause. I did something not right here. I'm missing something. Okay, so where's my dilation paper? I don't know where my dilation paper is, but I have an extra sheet. Okay, so we'll do it like this. All right, so let's go to dilations. Sorry. Let's go to dilations. Okay, so dilations, make sure you pause your video. So remember, a dilation is a stretch or a shrink. There's also a center of dilation. Sometimes they're basically the origin. Sometimes they tell you where they want to put it. It's a non-rigid motion because we are now changing to similar figures. One's bigger, one's smaller. They are similar, so they're proportional, but they're not the same size. So it's not congruent on these, okay? And if you read right there, all corresponding angles are congruent. All corresponding sides are proportional right there. All right, so we know scale factor. The letter for scale factor is K. So when K is greater than 1, so if we multiply by 1.5, if we multiply by 1.1, if we multiply by 10, it's getting bigger. It's an enlargement. Okay. But these notes said if K was less than 1, the dilation was a reduction or a shrink. Okay. And I don't like that right here. So I actually started writing K as less than 1. And I was like, that's not correct. Okay. A scale factor cannot be negative. Okay. So it can't be negative, right? So it has to be between 0 and 1, okay? Not including 0, because we don't want to multiply something by 0. So just above 0, all the way to 1, not including 1, because if you multiply by 1, it's itself, okay? So make sure you have that correct right there for the scale factor. If it's a fraction below 1, then it will shrink it. Okay. Now, if it's a fraction like 3/2, we know that that's an enlargement because it's 1.5. It's bigger than 1. Okay. So the dilation rule, this is easy to remember. All you do is take all of your ordered pairs and multiply them by the scale factor. Literally, that's it. Okay. Now, most of these are that we're talking about are going to be the origin as the center. We'll talk about when it's something different in a few minutes. Okay. So go ahead and graph number 1. So graph RST, and I think I might have already graphed it for you on your paper. If I did, great. So RST, if not, pause the video. So RST is my triangle right here, and it says K equals 2. So what you need to remember that is that that's the scale factor. So all you do is multiply each one of those by 2. So you could forego the graph and just say that R is negative 10, 2. T is 4, negative 2. And S is negative 6, 8. And then you can just graph those points. Okay, so I already did that. So I'm going to connect these. And I just want you to see that it's not always centered. So it's not always going to be something like kids assume that it's like supposed to be right in the middle. Okay, it is shifted a little bit. So just keep in mind, make sure that the shapes look exactly the same. Okay, just a little bigger or smaller than each other. Okay, I'm not going to do this one. All you have to do is multiply every single coordinate by 3, and you would have your ordered pairs. Okay, so hopefully that is a question on the ACT or SAT or something like that. Probably not that easy, but oh well. Okay, number 5. So number 5, I want you to pay close attention to a scale factor of 5 over 2. Okay, so with a scale factor of 5 over 2, that is actually a fraction, but it's over 1. So this one would be getting larger. Okay, so multiply each one of these by 5 over 2. Okay, so that would still be 0, 0. Multiply E by 5 over 2. That would just be 5. 5 over 2, 2 goes in there. It would be 10. Okay, so make sure you're able to multiply your fractions by 5 over 2. So 5 over 2, 2 goes in there 3 times, so that would be 15, 5. And G would be multiplied by 5 over 2. That would be 10, negative 5. Okay, so you could technically go right straight to your ordered pairs. Okay, and I hope you can. All right, what do you do if you have no points? Okay, so you actually have to get the ordered pairs. So if they give you a graph and say the scale factor is 2, the best thing for you to do is write the ordered pairs down. So 1, 1, 2, 3, 4. That's the point 1, 4. This is negative 1, 1, 2, 3. And so forth. And then just multiply everything by 2 and get your answers. Okay, same thing here, but to multiply by a 4th. Okay. All right. So right here, number 11, it says you don't have to do any graph. You don't have to do any points. It says A prime negative 10 negative 8 is the image of A after a dilation centered at the origin with a scale factor of 2. This is the image. This is the ending, right? This is the ending point. Okay, so what were the original coordinates of A if the scale factor was 2? What would I have to do here to get to my A prime or my A value? This is A prime. Divide. Okay. Oops, that's a 4. So this is actually a going backwards question. So divide by 2. Okay. This is the image. This is not the original point. After it was done by a scale factor of a third. Okay. So instead of multiplying by a third, I have to multiply by 3 to go back. So P would be at the point negative 6 times by 3, 15. Okay. Hopefully that makes sense. All right. This is the image after the dilation, right? This is the image. So it's a scale factor of 3 over 2. So I obviously multiplied by 3 over 2. So I actually have to multiply by 2 over 3. Multiply by 2 over 3. So the original point would be 2. And this one right here would be 16 thirds. Okay, it's not great, but that's okay. It's a weird point. All right, so I think you've gotten that. All right, how do we identify the scale factor in ones that are just pictures? Okay, so here's what we do. This is what I tell my 8th grade math students. So right here, I'm going to use F because it isn't a 0. So F and F prime. So F, let's see. So 1, 2, 3, 4, 5, 6. So F is at negative 1, 2, 3, 4, 5, 6, negative 3. So that's F. Okay, so F prime is at -2, -1. So you need to compare from here to here and here to here. What did I do? Okay, so it's going from F to F prime. So I'm dividing by 3. So dividing by 3 is a scale factor of 1/3. Okay, so don't go through all the ordered pairs. Just go through one set of matching ordered pairs. Okay. All right. So in this homework, I want you guys in homework number 9, I want you to do the odds again, but I also want you to try not to graph unless it's absolutely necessary. Okay, so I'm gonna go ahead and stop this video and then we'll do dilations from other points in a separate video.